Welcome students. So today we are going for the dimensional analysis of 10 plus 1 topic, and this topic is very important for your future course as well. So first of all we will go through the basic things. So first of all, the fundamental quantities. First of all, physical quantity. Now what is a physical quantity? Any quantity which can be measured is known as physical quantity. It's so easy. And this physical quantity is of two types. First of all, fundamental and derived. Fundamental means basic quantities. So what are basic physical quantities? The basic quantities are, just for example, mass, length and time. Why these three are known as fundamental quantities? Because they cannot depend upon each other. The mass not depend upon length, and length is not depend upon time. Obviously, if we are having two same size people, definitely their mass is not going to be same. And obviously the length of this marker is not going to change after 5 minutes. So which means mass does not depend upon length, and length does not depend upon time, and similarly mass is also not depend upon time. So which means these all the three quantities are independent from each other. That's why they are called fundamental physical quantities. So that's why they are known as fundamental physical quantities. Any physical quantity which not depend upon the other quantity is known as fundamental quantities. So the examples are mass, length and time. Now the derived physical quantities. Now the derived physical quantities which can be calculated by multiplying or dividing the fundamental quantities, which means let's take example. Speed. Now, you know what is speed? Speed is, yes, distance over time. And what is distance? Distance is length upon time. Now, length and time both are fundamental quantities. So, any quantity which can be derived by multiplying or divide the fundamental quantities is known as derived physical quantities. So it's very easy. You have many examples of that. You can take force, you can take acceleration, you can take power. So many quantities. These all quantities are known as derived quantities. The units of basic quantities are known as fundamental units or basic units. And similarly, the units of derived quantities are known as derived units. So that is the simple concept of fundamental and derived physical quantities, and fundamental units and derived units. Now we are having a concept of units. I am erasing that. Now, what is unit? Any physical quantity can be expressed in two ways, which means N into U, where X is known as physical quantity, N is number, and U is unit. Any physical quantity can be expressed is the multiplication of number into unit. Now what are units? Units are the formats we are given for measuring any physical quantities. Now there are basically three types of units are available here. So first is Standard International, SI, second is CGS, and the third is FPS. We basically using SI units. In Standard International, that is the other name of MKS system. that is the new name of MKS system. So where M is for meter, K is for kilogram, and S is for second. Similarly, CGS system, where C is for centimeter, G is for gram, and S is for second. Now, CGS system, centimeter, gram, second. SI system is other name of MKS, meter, kilogram, second. FPS system is not popular all over the world. It's only used in UK. So where F is for foot, and P is for pound, and S is for second. We are basically using SI and CGS system only. FPS system is only used in UK. Okay. So now these are the three system of units. Now we are moving ahead for the next topic, that is what is dimensional formula, and that is the main topic of today. So we are going for that now. So these are the basic things. Hope you know that. And now we are moving for the dimensional analysis. Now what is dimensional analysis? First of all, dimensional formula. Now what is dimensional formula? If we can express any physical quantity in terms of mass, length and time, if we put up any physical quantity in terms of mass, length and time, then that is known as dimensional formula. Some other basic physical quantities are just like current and temperature. For current we use K as Kelvin, and for current we are using ampere, and for temperature we are using Kelvin. So these are further some extra physical quantities which we can use in 10+2 basically. So that is known as dimensional formula for you. Now we are moving ahead for how we can make a dimensional formula. That is very simple thing. Now I am going to give you a procedure in which if you know the basic formula, you can easily derive the dimensional formula. And even I am going to give you a smart work. By knowing the dimensional formula, you can easily calculate the SI units of each and every physical quantity. Now just focus on that. So in this category we are just having any basic formula, and for this we are having dimensional formula, and for that we are now going to have SI units. Now say any physical quantity, just as area. Now what is area? Area is length into breadth, as you know. Now we can make a dimensional formula of length into breadth. Obviously there is no mass, so m0. Now there are two lengths, length and breadth. Breadth is also taken as length, so which means L square, and there is no time, t0. So that is going to be the dimensional formula for area. Now how we can make SI units? The SI units are taken as for mass, kilogram, for length, meter, and for time, second. Now that is the smart work now. Just put up kilogram, meter and second. Just put up those parts which we are having in the dimensional formula. Now we are having L square, which means the meter square. So the length square, the meter square, the length units are meter, na? So which means we can easily have the SI unit of each and everything. If you know the basic formula, you can derive dimensional formula, and you can also have the knowledge of SI units. Now moving ahead, just taking volume. Now what is volume? Length into breadth into height. Obviously now there are three lengths, so which means there is no mass m0. Now there are three lengths, so L cube. There is no time t0. So that is the formula for volume. And obviously length cube, which means meter cube. So meter cube is going to be the SI unit. And now the next one, we are moving ahead for let's take a dimensional formula for speed. Now what is speed? Speed is distance over time. So which means now distance is taken as length and time is taken as t. Now in this there is no mass L1. Now t is having the power of -1. So that is going to be the dimensional formula for speed. Now the units are, there is no mass, so kilogram is having no power. Length is having 1 power, which means meter. Now time is having 1 negative power, which means meter per second is going to be the units for speed. Speed and velocity are having same dimensional formula and same units. Now we are moving ahead for, you can say, acceleration. Now what is acceleration? Acceleration is basically velocity upon time. Now what is velocity? Velocity and speed are having same dimensions and dimensional formula. Now we can put up the value of speed from here or velocity from here, m0 lt minus 1 over time. So which means that is going to be m0 lt minus 2. Now in a similar format you can have no mass, so which means kilogram is having no power. Now that is going to be L, so meter. Now second is having a negative square, so which means meter per second square are going to be the units for acceleration. Now the next one is going to be force. Force is mass into acceleration. Obviously we are having the units of and dimensional formula of acceleration. Now just multiplying with it with a mass, so that is acceleration. So m0 lt minus 2. So the dimensional formula for force is m1 lt minus 2. So obviously the units are, because m is having power of 1, which means that is going to be kilogram meter per second, and that is also having a nickname of Newton. So Newton is basically kilogram meter per second square. You can easily assess SI units. If you know the basic formula, you can easily drive dimensional formula and you can easily drive SI units. Now, what is work? Work is force into displacement. Now we are having the dimensional formula of force, which is mlt minus 2. Now just multiplying it with displacement, which means L. So it is ml2t minus 2. Now just putting those values in terms of SI units. So kilogram meter square per second square, which is basically having a nickname of joule. Now you can further draw so many formulas. You have to remember just the basic formulas. You can easily drive dimensional formula and SI units. So just we are going for power. Now what is power? Power is work upon time. Now you have the units of work here and dimensional formula of work here. Now work is ml2t minus 2 upon time. So which means power is having dimensions of ml2t minus 3. Now just putting those values here. So it is going to be kilogram meter square per second cube. Now this is also going to have a nickname. Now power is having the units kilogram meter square per second cube, and that is known as watt. And if you are not concentrating on study, the teacher can give you impact of watt as well. Okay, so now the next one is going to be, there are so many formulas. Density. Now what is density? Density is mass upon volume. Now what is mass? Mass is m, volume is L cube. So ml minus 3 T0. Now you are having the units as kilogram per meter cube. Now these are the basic SI units and basic physical quantities. Now you can drive so many things. You can have a knowledge of so many formulas. You can make dimensional formula out of that. You can make SI units out of that. In the next video, we are going for the merits of dimensional analysis. Why we drive dimensional formulas. With the help of dimensional formulas, we can drive so many numericals, and we will do so many numericals in the second part of this dimensional analysis video. And till then, stay healthy and do whatever you want to do. Okay, so thank you so much.